Alright, today we are starting parabola. So here's your first parabola video. Just like on most of the other things, we have two different standard forms that we're going to look at. One standard form is x minus h squared equals 4p times y minus k. The other one is y minus k squared equals 4p times x minus h. So it just determines which one is squared. One of your terms, either x or y, will be squared. So here x is squared, so that means your y term gets the 4p. The y is squared here, so your x term gets the 4p. So let's go ahead and look at our graphs. The center is always located, or your vertex is located at h comma k. The focus is going to be p units from vertex. Your directrix is a line, negative p units from vertex. So just for the sake of convenience, I'm going to graph ours at 0, 0. So if our vertex here was at 0, 0, because x is squared, if you think about y equals x squared, then it's going to open up like a parabola. So we would have a focus. Well, here, let's go ahead and draw in our parabola. So here's our parabola. The focus is going to be located inside the parabola, and the distance between your vertex and your focus is p units. Your directrix is a line. You can either do it solid or dash. I'll take it either way. That's negative p units. So if it's p units, so if it's 2 units up to the focus, it's going to be 2 units down to the directrix. So your directrix is negative p units away. And those are all the parts we have of a parabola. So, again, you've got your vertex. Your focus is p units away from your vertex. Your directrix is negative p units away from your vertex. When x is squared, you'll write the equation of your directrix. Here, because this is a horizontal line, it'll be y equals negative p. That'll be the equation. If we look here at our, when y is squared, again, we're just going to put our vertex at 0, 0. When y is squared, we're going to open out to the side. Okay, so it's going to turn my parabola on its side. The focus is still p units away, but it's going to be inside my inside my parabola as well. So if my focus is here, this is p units. That means my directrix will be that same distance away in the opposite direction. This is negative p units, and this equation would be x equals negative p. There's a few properties that relate this p distance. One of the things that we'll look at more in depth is the distance from your focus to your parabola. This distance is 2p. So however far it is to get from your vertex to your focus, that distance from your focus straight out to your graph, to your parabola, is 2p units. So it makes it a little bit easier to plot your parabola more precisely. So we'll go ahead and draw it over here. This distance is 2p. This distance here is 2p as well. Okay, so let's get into some examples so we can actually see what's going on here. If we look at x squared equals 12y, you notice the difference between these two right now is it doesn't have the h and the k. That lets us know that our vertex is going to be at 0, 0. So because we're missing the h and the k, we know our vertex will be at 0, 0. We also don't have it written as 4p. You want to make sure it's written as 4 times your p value. So we've got our squared term, we need to rewrite this as 4p times y. So we're going to have 4 times whatever our p is, y. They have to be equal to each other. So in order to get 12, 4 times 3 is 12. That lets me know that my p value is equal to positive 3. So when we go and graph this, x is squared, so it's going to open up or down. X is squared, so we're going to say it opens up. The only way it would open down is if we had a negative p value, which we'll see when we do our assignment. So my vertex is at 0, 0. I'm going to plot that. My p value is 3, so we're going to go up 3 units, and that's where my focus goes. That means we can go down 3 units, and that'll be my directrix, which is a line. We'll talk about more in class what that directrix does and how it relates to our parabola. Okay, so our focus is at 0, 3. Our directrix is the line y equals -3. Then we want to make sure we plot an appropriate graph. So since this distance is 3 units away, if I go double that, 1, 2, 3, 4, 5, 6, we'll have a point on our parabola 6 units away from my focus. It'll also be 6 units in this direction, because this distance is always 2 times p. So since our p is 3, it's going to be 6 away. So we'll go 6 units this way, and that's going to let me know how wide my parabola is. And you've got your graph there. The second example, we run into a little bit of craziness. It is not in standard form. Notice you have your y term squared, so we know we're looking for y minus k squared equals 4p x minus h. We need to get it into this form, so we need the y minus k squared to be by itself. So we need this term to be alone. The first thing we'll do is subtract, so we'll have x minus 2. We're going to go ahead and put that in parentheses, because if you notice, my x and its common factor, they're going to be grouped together, so we're going to go ahead and do that, equals 1/8 y plus 3 squared. We need to get rid of that 1/8, and so we know if we want to get rid of a 1/8, we can multiply both sides by 8. So now we're going to have 8x minus 2 equals, now those cancel each other out, y plus 3 squared. Last thing to do is to put it in 4p form. So we'll have 4 times p, x minus 2, we know we need to get to 8, so 4 times 2, which I'm going to go ahead and label that as my p, will equal y plus 3 squared. My vertex is always at h comma k, so we look at the x term, comma the y term, so my vertex is going to be at 2, -3, again changing your signs. So if we go ahead and graph this, we go to 2, -3, and there's my vertex. Before we plot my focus, we need to make sure we decide, we need to decide which way my graph is opening. Because y is squared, we're going to be opening sideways. So that means to get to my focus, I'm going to go 2 units, it's a positive 2, so I'm going to go 2 units to the right, and I'm going right because my y is squared. So since y is squared, we're going to go sideways. That means I will go back 2 units to get to my directrix, which means we will be right on the y-axis. So my focus is at the point 4, -3. My directrix is x equals 0. And again, we want to plot a nice pretty graph with appropriate points. So since this distance is 2, we're going to go 4 units this way. So 1, 2, 3, 4. 1, 2, 3, 4. So that way I can draw my parabola appropriately. Okay, so that's how you graph it. Make sure it's in standard form, change your p-value, plot your vertex. You've got to decide whether it opens up or if it opens to the side, and then you'll go from there. The next thing we want to look at is how to write the equation. So we're going to go ahead and look at how to write the equation. It's just like we've gone before, we're just doing that same thing, only we're going backwards. So here it gives me my vertex is 1, -2, my focus is 1, 3. If you need to pause to write down these steps, this would be a great time to write them down, so then you can follow along as we go through each of the steps. Okay, so the first thing we want to do is plot our info. So we're going to plot our vertex at 1, -2, and our focus at 1, 3. Second step is to fill vertex into equation. Right now, all I know is that we're going to have something and something equal to each other. So my vertex is at 1, -2, so we'll have x minus 1 and y plus 2. Notice I haven't even decided which one's squared or anything like that. I just always go my x is on the left, y is on the right. The next thing we want to do is decide which variable is squared. If your points are lined up horizontally, your y term is going to be squared. If they're lined up vertically, your x term is going to be squared. Since mine are lined up vertically, then we know that x is going to be squared. So we'll put my squared on the x. The other side will get the 4p. So this is going to be 4p. The next and final step is we need to find p, the distance from the vertex to the focus. It's always from the vertex to the focus. So we'll have x minus 1 squared equals, from my vertex to my focus is 1, 2, 3, 4, 5 units away. That means my p is 5. So 4 times 5 is 20, and then we'll have y plus 2. That is my equation. We can go ahead and finish our graph. We know that since we went up 5 for my focus, we can go down 5 for my directrix, which would have the line y equals negative, let's see, 7. And then if we want to finish plotting our points, since we go up 5 to get to my focus, we would go out 10 units to get to my other point. So this would be at the point 11. We go 10 this way, so this would be negative 9. Here I'm just kind of guesstimating. And this would be a lovely wide parabola. Okay, so plot your info, fill the vertex in. One of them gets squared, the other one gets a 4p. You decide which one's squared based on whether it's a horizontal orientation or a vertical orientation. And then you're going to find p, which is the distance from your vertex to your focus. Okay, so you always want to make sure you do vertex to focus. If you're given the directrix, so for instance, if here we were given the directrix, this distance from here to here would have been negative 5. So we know the distance to my focus would have been positive 5, because they're always going to be opposite signs of one another. Okay, we'll do some more of these in class and work through them so that way we can clear up any confusion that you might have.